Hello, Elite Cohort 4. It's really nice to be back with you again today. For this video, I'm going to model how to do a one-way ANOVA test in SPSS. So what you'll see on my screen is that I have an output in Excel from Performance Matters, and it's my understanding that all of you have access to Performance Matters. So you may be able to pull a similar type of data set. If you're not able to pull this type of data set, you're welcome to use a fictitious data set, or you can use the data set that is directly in the lab if that is of preference to you. So what I have specifically for my data set is I have approximately 93 students who were each part of a different class. So I have class 1, I have class 2, and then I have class 3. And so class 1, the teacher focused on using a reciprocal teaching strategy all year. I have class 2, which is the teacher focused on using a close reading through annotation strategy all year. And then I have class 3, which is a backward mapping strategy. The teacher focused on using a backward mapping strategy, and which is also our control because that's the strategy that we typically use as a school. And so that there wasn't really no change to that teacher's practice. That's what we've been doing for years. But these two strategies were actually new strategies that we tried specifically for the purposes of looking to see if there was a significant difference that resulted as a change in strategy. And so class 1, like I said, received reciprocal teaching, class 2, close reading through annotation, and then class 3 received our normal strategy, which was backward mapping, where we break down paragraphs and put them into a graphic organizer for the kids to analyze them that way. And so what I've done is I've already taken this data set right here and I've moved it over into SPSS. So you're able to see what it looks like in SPSS. I just simply copy and paste it. And so what we have here is if you go to variable view, what I've done is I've changed the first variable name to class. The second variable, I've named it key ideas and details score. I've decided to make both of my variables numeric. You may see that some people who are using SPSS or some researchers, they would change this to a string variable, and they would actually label, instead of using numbers 1, 2, and 3, they might label it with the actual name of the treatment that was received. So you would see reciprocal teaching, you might see annotation, or you might see control. And one of the things that I've learned about this SPSS program is that the version that we use does not play nice with string type variables. And so I've decided to keep it a numeric variable because I find it very difficult with this version of SPSS to use a string variable. I want to make sure that my measures are set correctly. My class is a nominal variable, and that my group is a nominal variable, and that my score is a scale variable, scale measure. And so I just want to make sure that those things are set correctly. Otherwise, we will not be able to correctly run the data and the report and the analysis. So now what I'm going to do is I'm actually going to go back to my data view, and I'm going to click on Analyze to run my one-way ANOVA. I'm going to go to Compare Means, the same area that we were in for our t-tests, and then I'm going to go down to one-way ANOVA, and I'm going to click on one-way ANOVA. In order to run my one-way ANOVA, I'm going to move my KIT score over to my dependent variable list. I'm going to move class over to my factor. For this test, I want to run post hoc tests, and I want to run 2 post hoc tests. For you, you're only going to run 1. For me, I'm going to run 2 because I want to give you one for each scenario that you could possibly encounter. If your data set has an equal number of participants in each group, for example, class 1 has 30, class 2 has 30, and class 3 has 30, you're going to want to use 2key. If your group sizes are different, then you're going to want to use the LSD test. My group sizes have slight differences. I have one group with 30, I have one group with 31, and then I have one group with 32. So I've decided to use the LSD test today. I am going to still include the Tukey test so you can see what it looks like, but you only need to include the one that makes the most sense for you. Because I have different numbers in each group, I'm going to use the LSD test. But again, if you have the same number of participants in each of your groups, then I recommend using the Tukey test because it is a more conservative test, and more conservative is better. But you have to have equal numbers in each of your groups in order to use this test and use it correctly. So once you've clicked on the equal variance as assumed test that you'd like to use, go ahead and click continue. Next, you're going to click options. For options, you're going to include descriptive statistics. And then I also recommend that you include homogeneity of variances test. And then you're going to click continue. Once you have all of that set up, you're going to click OK. And when you click OK, it should give you an output. Let me just check my time. It should give you an output. And the output is going to show you several tables. It should show you a descriptive statistics table where you can look at the means of each of your groups. You're able to see your confidence interval. So with 95% confidence, if you were to take this sample and generalize it to a population, the true mean of the population would be somewhere between 34 and 51 based off the sample that's here with 95% confidence. As you can see, it also gives you a minimum and a maximum for your range. For my group 1, the minimum score was a 0 and the maximum score was 100. Group 2, 0 was the minimum, 91 was the maximum score, and then in group 3, the minimum score was 13 and the maximum score was 81. Again, you can see that the 95% confidence interval changes with each of the groups. For example, my third group, which is my control group, has a confidence interval range there. Anyway, 95% confident that the true mean, if generalized to the population, would be between 33% and 48%. It would fall within that range based off this sample. Okay, so we have our homogeneity of variances test. We have our ANOVA. We have our multiple comparisons, our post hoc tests. Remember, I said that if you have equal numbers in each of your groups, you're going to use the Tukey test. I do not have equal numbers in my group, so I'm going to interpret and read the LSD test. We are not going to use that test right there, and so that should be fine. Okay, so what I'm going to do is I'm actually going to now switch over to my PowerPoint. And I'm going to, because I've labeled it for you, so that way you can see all of the information appropriately. So one thing that I would like to point out is that the text for this class is a wonderful resource. So if you go to pages 333 through 347, you're going to see that there's really, really detailed explanations for everything that I'm going over today. And so I really recommend reading those pages to complete this lab, 333 through 347. I also want to point out that application 10.2, which is on page 347, is an example write-up, which you can use as a mentor text for your lab. I really recommend you look at this application before completing your lab, because it really models very nicely how to do a nice analysis write-up, but also a nice discussion write-up for the lab. So moving on, we have our one-way ANOVA descriptives. I already went over the descriptive table with you just a second ago, so I'm going to go ahead and skip that. But I do want to show you the tests of homogeneity of variances. So as you can see, when looking at my mean, the significance level is greater than 0.05, which means that there is homogeneity of variance, or homoscedasticity, which means that I am able to go on and interpret my ANOVA table because there is appropriate homogeneity of variance. If this were lower than 0.05, then I would not be able to use the ANOVA, and I would end my analysis at that point. This does have to be greater than 0.05 to continue with your analysis. Next, I'm going to look at my ANOVA table. Because my SIG, or my significance value, in my ANOVA table is greater than 0.05, it means that there is no statistically significant difference between the means of my three groups. Thus, I'm going to fail to reject the null hypothesis. I can't reject it at this point because my SIG is greater than 0.05. Again, you are going to use your multiple comparisons table. If you have equal numbers in each of your groups, you're going to use the Tukey test. If you do not have equal numbers, you're going to use the less conservative LSD test. Because I do not have equal groups, I'm using the LSD test, and I'm going to look at the significant levels for each of my variables. So as you can see, I have group 1, and when you compare my class 1 to class 2, there was no significant difference. When you compare the mean of class 1 to class 3, there is no significance difference. This is greater than 0.05. When I look at this one, class 2 to class 1, again, no significant difference. Class 2 to class 3, no significant difference. Class 3 to class 1, no significant difference. Class 3 to class 2, no significant difference. So as you can see, there's a lot of information here saying that there is no significant difference. I did not have to analyze this table because my SIG, or my significance value, or my p-value, was greater than 0.05. I could have stopped my analysis there, but I did want you to see the multiple comparisons table. So in case you do have significance, you're able to see exactly where your significance is coming from. Maybe you have significance between class 1 and class 3. Maybe you have significance between class 2 and class 1. This table actually tells you exactly where that significance exists, because it may not be between all three groups. You may only have significance between two of the groups. And so this multiple comparisons table does a really nice job of giving you the information that you need for that. The other thing that I wanted to point out when you're looking at the Tukey test or the LSD test is that the confidence intervals here are crossing 0, which means that the true value of the mean could be potentially 0, which means that that's not an acceptable result. So what means if you were to take a sample and your sample has 0, that means that the true significance would be 0, or the true result would be 0, which suggests that if you have a population with 0, it's not acceptable to be statistically significant. Let's see. And then, of course, you get your means by group graph. Your means by group graph is just showing you in graph level what the mean of each group was. As you can see, my control group, which was group 3, actually does have the lowest mean. Group 2 had a slightly higher mean. Group 2 is my close reading through annotation. And then group 1 was my reciprocal teaching. It looks like the class that received the highest mean was my annotation group. However, even though they have the highest mean, it is not statistically significant. And so I once again, I have to fail to reject my null hypothesis. And that should be it for right now. Let's see.